Hi everyone, today I'm going to be briefly talking about an SBIR program that we've been working on for NAVSEA titled Undersea Network Performance Modeling and Cost Tool. So before I start about the specific SBIR program, I'd like to give you a little bit of background into our company, Makai Ocean Engineering, and what we do. So we are a professional ocean engineering service provider that has been in business since 1973, which means this year marks our 50th year in business. And we're known worldwide for a few specific technologies, the first of which is our subsea cable software. We sell our software globally and are considered the world's #1 provider for planning and installation software for the long telecommunications cables that support our communications globally. We're also a world leader in a couple other areas, including marine pipeline design and a couple renewable energy technologies, including ocean thermal energy conversion and seawater air conditioning. So we have a significant technical history in which we've been involved in numerous SBIRs and STTRs related, mainly surrounding subsea cable hardware and software again. And we hold several patents for the technologies that we've developed under these programs. Our key resources include, most importantly, our 39 employees, 30 of which hold advanced degrees of higher than bachelor's, excuse me. And then we have 3 offices. We have 2 in Hawaii and a third, most recent office in Ventura, California. We also have a significant commercialization and transition success from our 50 years in business. We have transitioned a number of our SBIR technologies to phase 3s within the DoD and also commercialized some of these technologies. So from that success, we were a 2016 Tibbetts Award winner. We also have an SBA designated Commercialization Achievement Index of 100 out of 100, which we've held for the last 15 years or so. And then Makai's products, as I mentioned, are used globally by both the US government and commercial clients. So the Navy's challenge, as it was laid out in this SBIR topic, is the following. So the objective that was laid out is they wanted a tool to automatically generate the most efficient and lowest cost cable routes, and then also simulate the system performance of these subsea systems that the cables are connecting. The expected transition target at the Navy includes the maritime testbed, which is the primary and near-term transition target for this technology. And in addition to that, general subsea networks within the Navy, and then also other subsea cabled infrastructure projects. The expectations that they laid out is they would like to minimize the cost of undersea cabled systems by automating that design process. They wanted to also increase performance of these undersea cabled systems. So instead of separately doing costing and routing and performance modeling all in separate processes, they wanted to combine those to increase all of them. And then, of course, they wanted the tool to generate routes that conform to all of the installation rules of thumb. So on this slide, I'll talk briefly about the Navy's operational need and the improvement that they're looking for. So the need is to develop a software tool to increase automation in the design and optimization of subsea cabled systems. The improvement that they're looking for is they wanted a tool to reduce the time and cost of subsea cable design and planning. And then the problem of existing methods is it's a very labor-intensive, lengthy, costly, and highly iterative process that takes several weeks for each project. So they're trying to reduce that time to commissioning and also, of course, the cost. And then the primary organization with this need is our government customer at NAVSEA. So now I'll start getting into the solution that we've developed. So what we've developed is an automated planning tool. And this tool, basically its capabilities include the ability to automatically route subsea cabled systems and also develop costing for those systems, and also include functionality for performance testing of the subsea cabled systems and the systems that they're connecting as well. The specs that we project for this tool is the ability to automatically generate the most efficient and lowest cost cable route, and the way that we can validate those specifications include comparing to manually engineered cable routes. And then also another spec that we need to achieve is the ability to conform to all installation rules of thumb when this automated software is developing those cable routes. So the real key innovation of what we've developed here is the ability to reduce the time and basically eliminate the entire manual route engineering and costing processes. So this slide shows the current status of this SBIR project and the technology that we're developing, including some of the milestones that we have completed and those for the future. So we're currently at a TRL 5. This slide is a little dated, so it says we're at a TRL 4, but we are at a 5 since passing into calendar year 2023. And we plan to reach TRL 7 in 2024, where we will actually demonstrate our prototype software in an operational digital twin environment. And as you can see here, we plan to reach a TRL 6 by the end of this year, where we will develop our full prototype software and test it on the maritime testbed digital twin. And we're currently in our phase 2 base period. So I think this is one of the most important slides for some of you watching, which shows the key features, advantages, and benefits of the software that we've developed, and comparing that to the current ways of doing these cable route developments. So one of the most important factors is the development time. So we're basically reducing that cable route engineering time from several weeks down to a several hour process. Additionally, our software includes performance modeling that is performed in real time automatically by the software itself, compared to the current methods, which again are very manual and require expert trained personnel to manually do calculations and modeling prior to the cable routes. And we're able to do that automatically in real time as the routes are being developed. Another great tool for our customers, and a big advantage for commercial customers as well, is the fully automated cost estimation that our tool provides, compared to, again, very manual, iterative costing process that requires expert personnel. And then a key feature for future cable development, and something that can really change the industry here, is that our software will automatically consider constructability of those cable systems. So our software will automatically ensure that any routes that are developed will conform to all of the installation rules throughout that development process, versus that typically requires expert knowledge of how to actually install these cables as you're developing a route. So hopefully this can kind of reduce the expert manual process that's currently being required. And then at the bottom there again, the key feature there is automated simulation and route development, which both improves performance of these cabled systems and also reduces the time and cost for that planning stage of these projects. So many of you might be asking, what is the future of this technology and what is the path toward transition to the fleet? So what is needed beyond the phase two? Luckily, our program has all the funding and roadmap laid out for transition to Navy programs. Our Navy customer is very supportive of this technology and capability, so things look good there. The primary need at this point is to perform a test of our software and compare it with manual methods. Going back to that schedule on the last couple slides, those tests will be critical towards reaching transition. We are looking for some transition advocates on the commercial side. Some markets include offshore renewables and other subsea cabled infrastructure. So if any of you work within those industries and have an interest in this tool, we are definitely interested in talking on those applications. So here's my quick pitch to anyone that's interested in being a transition or commercialization partner or advocate. First off, our business model is the same that we use for our existing subsea cable software, in which we sell licenses to use the software to our customers. And then we also provide a subscription service to our customers where the money they pay annually pays our engineers to constantly upgrade and maintain our software to make sure that our customers are getting the tools that they need to actually do their job. Some other transition paths that we envision for this technology, first off, is any future subsea cabled infrastructure projects. There's a wide variety of applications, so I'm interested in talking with any primes that have ideas there. And then one market specifically that's of interest is the offshore renewable energy market. This has been talked about a lot lately within both commercial and government sectors, specifically offshore wind. So we'll be targeting that market specifically in the near term and then other offshore renewables in the future. So we're definitely interested in talking to any transition partners that work within that industry as well. So I appreciate you all taking the time to watch and listen to my presentation today. And the last thing I'll leave you with is please reach out to discuss your needs. If you are one of those transition partners and you have some commercial or federal interest in this technology, please reach out. My contact information is below. I will also be at the West 2023 conference, so feel free to reach out to me if you'll be there, and I'm happy to schedule a time to talk. All right, thank you.